This test, all right, this one sample T test, this company which developed batteries, is trying to prove that their batteries last over 5 hours. Okay, so we're going to get into the first thing. Hopefully you guys remember what to do. I know it's different, but still very similar. But first I want to make sure you know how to type in the stuff. All right, so turn your calculator on. All right, and we're going to type in all of these data values into a list. All right, so we're going to go to Stat, Edit, and I'm just going to type them right into list 1. Okay, so I've got 321, 295, 332, 351, 281, 336, 311, 253, 270, 326, 311 again, 288. All right, so we're actually going to type them in and then just kind of ignore it for a second. Oh, yeah, of course. All right, so what's the first thing I should do? No, you don't have to. So on this one, there's just one sample. All right, so one group of data. So really, I just need one list. You'll see when you come back from your retreat that we're going to do some 2 sample t-tests where I am going to need both.
Okay, so we need 2 samples.
So right now, just one list.
So now we call it 2 sample t-tests.
Right now, it's one sample t-test, but that's coming, yes. So what should I do first? No, that's coming very soon. What's the first thing you should do when you run a test, any test? Parameters, right. So remember the phrase was let, don't do it. Oh, Marie, you did it. I'm just kidding, you're fine. Let P, but no more P, right? No more P. Now it's let, not T. You're going to get it. It's going to be mu. That's coming, Diana. Mu, right? Okay, it's only 9:48. What do you need from me? Like, why are you calling me? Oh, they hung up. Even better. I love it. Gosh, keep hanging up. All right, so let mu represent. You know what? Just fast forward. All right. Let mu represent the population average battery life for all the batteries. Wasn't my best sentence, my bad. All right. So ultimately, I just need you to make a statement that defines mu to represent the population mean. All right. You can say the word mean, average, they're the same thing. Okay. So essentially, do I know this? Do I know the average battery life for all the batteries that they make? No. I do not, right? There's no way to know that, right? So we're going to take this sample that we have and use that to run a test to see if they are now achieving their new goal. They want this battery life to be what? 300 minutes or 5 hours. I want to actually be over that. They're trying to prove that, Thomas. So my null hypothesis is that the mu is 300. What are they hoping it is? Over, so we're going to use greater than. Nice. So those are the hypotheses. Any questions on the parameter, and hypotheses? Yes.
So you determined that the null would just be equal to, not more than.
Correct, because whatever we want to prove, which if we're being paid by this company as a consultant, we're trying to prove that the company is making better batteries. That's what we want us to prove. So we always want what we want to prove in the alternative hypothesis. Yes. All right. Luis, you almost done?
Yep.
Okay. You're going home after you're done. Okay. All right. Let's get to the assumptions and conditions. Let's send a quick chat. What's the first assumption? Independence. Who's got it? Who's got the statement? Stop calling me. I'm sure, because they realize like they don't like to call me because I get mad at them, and so then she probably realized, oh, I shouldn't call him. I should chat him. Now she's chatting me, and now she didn't get a response immediately. So, thank you, Luis. Appreciate you. You know what? Cool. I hope who's gonna watch it? Come on, right? Honestly. By the way, thank you for doing that.
Battery life, one battery.
You're good. I get it. Exactly. One battery. I don't know how long it lasts, right? Whether it's over 300 minutes, exactly 300 minutes, under 300 minutes, what's like a really bad one, really good one, doesn't matter. So, all right, independence, assumption. Remember, do you need to put this title here? You do not. So one battery's life won't affect another. You're welcome. All right, do you know if that's true? We do not know if that's true. We hope it's true. All right, so we're hoping that when we look in our very minimal amount of information, that it says something about randomization. Does it? Is this a random sample of 12 batteries?
No.
It doesn't say that. So you guys remember the go-to sentence? That sounds good. I was going to say these 12 batteries are a good representation of all batteries. Okay, the 10% condition. So far, this is no different than what we did last unit. This is a pretty small sample, bless you. Pretty small sample here. So multiply by 10. So 12 times 10 is 120. Do they make more than 120 batteries? I'm assuming they do, unless these are the most expensive batteries ever produced in the world, right? Otherwise, they want to make money. So they produce more than 120 batteries. All right, so our sample size is not too large. Now, normally, this is where I would say we got to make sure that our sample size is large enough, but we're not doing that anymore. Okay, I know, something new, something different. We're going to assume that if I had, let's assume they make millions of batteries, if I had the data for all of the batteries in their entire battery life, and I looked at the histogram, that histogram better be unimodal and symmetric. Do I know that? I don't. So we just have to assume it. This is called the normal population assumption. Okay. The histogram for all batteries would be normal. And if you wanted to write down unimodal and symmetric, that's fine too. All right. We cannot actually know if that's true. So what we do know is we have the actual data from our sample, which is 12 batteries. So we're going to check a histogram. So we call this the nearly normal condition. All right, so we're going to go back into our calculator and check to make sure our histogram looks roughly symmetric and unimodal. Is that good? Okay. We ready to make a histogram? It's been a while, hasn't it? Since the midterm? For some of you?
Can we get them back?
Absolutely. No, you can't. But we can go over it. They made us turn them all in. I don't know. Okay, ready? All right. Do you remember where to go? Yeah. Nice. So I'm going to do second y equals, which is stat plot. So second y equals stat plot. We got to hit enter, and we want to turn it on. And do you remember which one is the histogram? Nice. Okay, and we put our data where? List one, so that's all good. So we're good to go. You've turned it on. Hit graph. Oh no. Zoom. And if you don't remember what number it is, it's zoom stat, which is number 9. Zoom stat. Hit enter. Ah. Your brain remembers amazing things. Like yesterday, my wife and I were playing Mario Kart with Henry, and we were talking about a map from when we played Mario Kart when we were like 10 and 11, and she remembered the name of the map. Banshee something, where like there's like holes in the wood. It was a tough map. Tough. I struggled with it. Yeah. So anyway. Okay. What do you guys think? Does it look unimodal and roughly symmetric? Guys, remember, low bar here, right? Low bar. Unless you see something like, whoa, that's a really like highly skewed possible outlier. Unless you're seeing something really like, wow, eye-popping, we're going with it, okay? So you do need to sketch it. All right, you do need to sketch it. Doesn't need to be beautiful. I think that's it. And this is what? Battery life. And I'm going to put this is in minutes. You do not need an axis for the Y. Just labeling what we just did. Okay? So this, I'm going to say this, histogram is unimodal and roughly symmetric. Now here's the deal, guys. What if it wasn't? What if it wasn't? What are you going to do on the AP exam if it wasn't? Don't do that. You're not gonna like write that it is, right? That would be obviously wrong. No, you're going to say that this is showing skewness. Maybe it's bimodal. Maybe there's a potential outlier. You're going to mention it, but you're going to keep going, and you're going to say that worries me a little bit. All right, what's my sample size in this one? 12, not very large, right? So let's say that this histogram, all right, showed some skewness, all right, in whatever direction you want to, all right? But then I told you that the sample size instead of 12 is actually 12,000. What would you say about that sample size? Much higher, right? So the higher your sample size is, the less I care about this, okay? When your sample size is small, I really need that histogram to be unimodal and roughly symmetric. When your sample size is large, I really don't care what it looks like. We love large samples, right? Exactly, okay? So because the sampling distribution models that are created from this, when you have a really large sample, it doesn't even matter if the population shows skewness. You can still use the normal model. In this case, the T model. Yeah.
Is there an example where like this doesn't happen?
I'm sure it could come up at some point, but again, it's not a huge deal, Thomas. Just make a note. I'm worried about this not being unimodal and roughly symmetric with a small sample size, but I'm gonna still, it's period. And then just keep going, right? I just get kids that are like, yeah, well, it wasn't perfect, so I just stopped doing the question. I'm like, don't just stop doing the question, you got to finish it, okay? That's fine. Yeah. Yeah, exactly. All right. What statement? Do you guys remember the statement?
Flow conditions have been satisfied. I will use. Is it like
No. So we used to use what model? The normal model. Now we're using the T distribution model or T model. All right. So that will be new. So girls, when you take your quiz on Friday, that will be new. I like the excitement. Hearty sigh. To run, we're not saying the P word, Victor. To run a one sample T test. And if you just wrote Maria T test, that's fine. I'm just trying to be very specific on how many samples I have. Now I know this is not the same, but you guys see how this is very similar, right? And this is the case from now until we're done, all right? So I know it's not easy, right? But at least I'm hoping that because there are similarities, it'll be easier to kind of memorize this stuff. Well, what we're gonna do, a couple of things we're gonna do. We're gonna do, once we finish all the tests, Maria, we're gonna do a review where I kind of mix them all up. All right, we'll do a Kahoot where you read and you have to decide what test you would do. All right, so we're gonna have lots of opportunities for you to like read stuff, not necessarily do all the work on the back end, but at least decide when I read this on the AP exam, what should I do? Right, because that's the trickiest part, right? When you take my test for this in March, you're going to be like, all right, well, I know it's got to be either a 1 sample t-test, 2 sample t-test. Exactly. That's what's hard about life. You don't know what to do. I know how to do all the stuff. Which one do I do? Okay. Ready for the mechanics?
Yes, sir.
All right. So we have our sample size, which is 12. All right. Now watch. I write this DF. Do you guys know what that stands for? It's okay if you don't. It's new today. Degrees of freedom. All right, you want to put that down. Right now, it's easy, it's simple. It's your sample size minus 1. Your sample size minus 1. So in this case, degrees of freedom is 11. All right, I'm going to write down Y bar. Do I know Y bar yet? Joseph, you done? Yeah. Come on in, man. You're going to have to move that one over. Yeah. Thanks, sir. Do I know Y bar? Are you moving that one in too? Look at that. I was going to say just move yours in. But thanks. Do I know Y bar yet? No, we're going to find it here in a moment. All right, and then I also need S. Do you remember what S is? Sample standard deviation. Okay? So make sure you have those things memorized. And we're definitely going to do a Kahoot on symbols before we take the AP exam. Yes, got to know your symbols. All right. I don't really know how to do this because, like, when you run the test, you can actually get all this stuff. So let's do that. Let me write all the formulas down, and then I'll run the test, and we'll fill in the blanks, okay? So we have to find our t-test statistic with 11. Why did I write 11 as a subscript? I got you. It's the what? Don't say TF. It's the degrees of freedom, right? Degrees of freedom is equal to Y bar minus mu over the standard error of Y bar. Who's got that formula? Thank you so much. Remember, do you have to have that memorized? No, they will give you that one. But just like pretty much all the formulas, they don't really give it to you. But they do, but they don't. All right. On Thursday, when you were here. Did you pick it up? All right, let's run the test. Thursday.
I can't remember if I was here.
But yes, no worries. Okay, ready? Calculator time? Yes, we're ready to do the buttons. It's your first time you're running a 1 sample t-test, right? You will never remember this. All right, ready? Stat. Test. Oh, test. Okay. Now go all the way around wherever you want, but you're going to find out that it's actually number 2. Okay. Now it says, how do you want to input the stuff? Basically, this question is saying, did the AP exam give you the data, or did they give you the sample statistics? All right. Did they give us the average from our 12 batteries for the battery life, or did they give us the actual 12 data values? The actual data values, and where did I put them? In list 1. So I'm actually going to go over to here, or actually leave it at data, but if they'd given me the actual sample statistics and not the individual data values, I'd be going over to stats to type that in. I can show you what it looks like. Click it, right? So you got to know Y bar, X bar. You got to know the sample standard deviation. You got to know that stuff, okay? We don't know that stuff yet, so we're sticking with data. What did we say the company thinks right now is the best idea for the average battery life for the batteries they make? 5 hours. I'm going to put 300 just because all the data values were in minutes. All right, so I'm going to put 300. I'm going to leave list 1 alone, right? That's where we put it. Obviously, Joseph, you haven't yet. All right, and then what symbol did I use for the alternative. Greater than. All right. You don't have it? Oh, okay. Something about that desk. Students that sit at that desk never have their stuff. It's not just you. So another student. I won't name that
I
student.
mean, I just wasn't.
You were.
I can't remember. But thank you.
Do you want the reading guide? Carolina didn't want it. She said she's not going to do it. Do you want it? No, thank you. Sorry, I didn't mean to say your name. Okay. Hit calculate. Now, I know there's a lot of stuff going on there, but I just want to first rip from it the sample statistics. So I want Y bar. This will say X bar. So 306.25. 306.25 minutes. All right, and what is that? What is 306.25? That's the sample mean. Very good, right? That's our average battery life for these 12 batteries. Which, hey, we're not there yet, but hey, I mean, that's what I noticed about that, it's above 300, which is what we're hoping for. Now, the question will be, is it high enough above that we have enough evidence to reject 300? You'll see here in a moment. What's our sample standard deviation? 29.31. So now if I put all this stuff in here, I have 306.25 minus 300 over 29.31 over the square root of 12. Guys, am I typing that into the calculator? No, because they've already done it for you, right? The calculator has already calculated the t-test statistic, right? And what is it? It's, where it says t, 0.739. 0.739. All right, do you guys see how the next slide is blank? Yes, I'm going to draw. Is it not blank? No? Okay, next slide is blank. I'm going to draw my t distribution model. You guys ready? Watch, see how different it is. Here's my t model. See how different it is? It was a joke, guys. It's not any different, right, than my normal models. Thank you so much. I appreciate that. Right, thank you so much. So again, when you do this, don't be like, oh man, I better draw a t model. Just draw the same thing you've been drawing. We know this is the t distribution model. Where is 0.739? Like here? And not that far, right? Which way am I shading?
To the right.
To the right.
I was thinking.
All right, here's my p-value. This can take the whole thing because I have another slide after this where we're going to write down your conclusion sentences. Our p-value is 0.238. I didn't clarify, so what alpha am I using? 0.05. And let's see, again, I know this is the first time you're doing a t-test, but at this point, is it really any different than what you've done? No, you've got your p-value, you've got your alpha level. What do you notice? The p-value is above alpha, so I don't have enough evidence. So what am I going to tell the people that hired me at Batco? I'm going to tell them, based on what you gave me, I don't have enough evidence to say that your average battery lifespan is over 300 minutes. And you could say, Jonathan, give me more money, right? I'll do it again, but give me thousands of batteries this time. Maybe your sample size was not large enough. You don't have to go into that detail, but that's something you could say. All right, here we go. Let's write the sentence. Conclusion. The p-value is above my alpha level, so I will fail to reject the null hypothesis. At this time, I don't have enough evidence to say the average battery lifespan is above 5 hours.